In our previous video, we saw that rate of change is nothing but the slope. It's positive when the function is increasing and negative when the function is decreasing. And at these peak and valley points, where the function is neither increasing nor decreasing, we say that the slope is 0. Today we will take a look at the average rate of change. But before that, do you remember this slope formula we studied in middle school? Imagine we have 2 points, 2, 4, and 7, 10. To find the slope, we take the change in y over the change in x, so that's 6 over 5. This number tells us exactly how steep that straight line is. But in the real world, most things don't move in perfectly straight lines. In higher level mathematics, we need a formula that works for any function, even the curviest ones. Let's pick 2 points on this curve. For the first point, let the x value be a. Then the corresponding y value is f of a. And for the second point, let the x value be b. In that case, the corresponding y value is f of b. Now, if we connect these 2 points with a straight line, that line is called the secant line. Even though the function itself is curved, the secant line is straight. And because it's a straight line, we can easily find its slope between the interval a and b. The change in y here is f of b minus f of a, and the change in x is b minus a. And this is what we call the average rate of change. It's simply the slope of the secant line connecting 2 points on the graph.